In this video, I'll show you how I used an Arduino Micro to add a throttle that mimics the pedal input, allowing quote-unquote throttle to max speed instead of capped at 20 miles per hour as the factory throttle is. This green momentary switch acts as a throttle, and the red on-off switch, when engaged, simply bypasses it, allowing the bike to return back to normal pedal assist. So a few things to note: speed can still be adjusted as expected using the 1 through 5 of the factory settings, and the factory throttle still works as expected up to 20 miles per hour. Got my little throttle right here. Over 20. When you open this up, besides the battery cover being unplugged there, you find this one, you unplug that, and then that's where our wires are going to go. Here, instead of cutting any of the actual factory wires, we're going to plug in a 3-pin extension, which I'll link all the items that I bought down below, and then we're going to splice those wires off the extension. This is more of a mess than it would need to be. It ended up being that I only used the yellow wire that comes out of there and not the red and black wires. So the red and black wires could essentially just stay connected, and you could simply splice open and cut the yellow wires and run them up to your microcontroller. In addition, you don't really need that 12-volt converter that I have there. I had that in place because I had previously tried it with 12-volt relays before going to the Arduino. You could just power the Arduino off of the USB port up top. I put it all in this box. There's an enclosure for this little project box. There's the Arduino Micro. And because let me get this to focus. Because I already had a 12-volt power supply, just a simple 48-volt to 12-volt converter, I'm running the Arduino off of 12 volts input to the voltage in, ground, and then over here at pin 13 is the Mosfet connected directly to the gate, and then the two outputs, the one on the left and the one on the right, the one on the left going to the controller, and the one on the side on the right, the yellow wire going back to the cadence sensor. That's really about it. And then here I just have a double pull, double throw switch, and that's doing on and off, as well as bypassing a secondary bypass for the system to return it back to just the normal pedal assist. This is what it looks like with the cover back on. And here is a simple wiring diagram showing the Arduino with D13 going to the gate of the Mosfet, and then the drain and source sides of the Mosfet. So the drain and source of the Mosfet are directionally, they need to be connected in a certain direction. And so I found that out by trial and error. It didn't work the one way, but it does the other. So if for some reason you hook everything up and it's not working, try reversing that. Here's a screenshot of the Arduino code that I used. The on-off frequency I found to work best was an on time of 98.9 milliseconds and off time of 74.9 milliseconds, which should be a wave pattern of approximately 5.75 hertz. I tried a bunch of different on-off patterns around that timing, Seemingly slower patterns worked well, some of them going up to almost max speed, others going just up to like mid 20s. So I played with the timing quite a bit and landed on the 98.9 and 74.9. And then I even tried some trapezoidal and sawtooth waveform patterns, but none of those worked at all. So I'm not going to sit here and pretend to know exactly how the factory pattern expects it to look, but feel free to play with the timing, change it, and let me know if you come up with anything that works better. I hope this inspired some of you guys to try your own version of this, probably with a little more additional coding. You could hook up a variable speed throttle instead of the simple on-off momentary switch that I used. I look forward to seeing what everyone comes up with. Feel free to reach out to me in the comments or on my socials if you have any questions.